Sound pretty good so far?
Yeah. Victor, can you give me a
Yeah.
use case for that?
Like you're
Can you?
saying for adjusting
Yeah,
that C?
right.
Yeah, so tell you what, I will go ahead and pull it up from here. So we're actually going into the kernel trick, but I'm going to go ahead and show you this Scikit-Learn example. And I'm going to go ahead and plot this. Oh, of course, I didn't have it run the first five through.
I mean, I hear
Sorry,
what you're
this is,
saying. I just can't,
yeah.
I can't see how I would use it or what data set I
Mhm.
would use this for.
Oh,
What
okay.
type of data set I would use this for.
Yeah, this all depends on like saying how much are you okay with saying, or are you saying when would you use a support vector machine, or when you would use the C parameter?
Both, actually, both.
Yeah.
Both.
So a support vector machine, and just like for any machine learning algorithm, you can use it for really anything. You can use actually support vector machines, one for classification, saying like, oh, okay, like are these different groups, how can I separate these groups? But also it can be used for regression as well. So you can actually use, I think in Scikit-Learn, it's not an SVC, it's an SVR for regression. And so you can do the same thing that you did with like anytime, think of it like anytime you use a linear regression, you could use support vector regression. If you have, anytime you would use a logistic regression, you could use support vector machine for classification. So a lot of things I would say overall is that in general is that, and there are going to be some caveats I'll say in a second, but any machine learning algorithm you have, you could likely use that for any data set. And it turns out that playing with the hyperparameters, there's a theorem that basically says you can get basically the same amount of accuracy with different algorithms, like different machine learning algorithms, and still approach the same accuracy if you can fine tune those hyperparameters. Now, the big part of it is going to be saying, not so much of saying, oh, okay, like this support vector machine can only be used for this kind of data. It's that it will perform better. And I say perform better, it means that it's easier to train on certain data sets. So support vector machines tend to have a hard time when there's many, many features, because basically because of this L2 regularization is that it'll tend to want to keep all of those features in there. So if you have many, many features, it's going to have a hard time converging into a global minimum, basically like the best answer. However, they can be really useful when you're trying to define these different, different boundaries. So if you really care about that boundary, it'd be really useful. Decision trees are really quick and everything, but they're not really great with boundaries. They're going to tend to overfit all the time. So one option is to say, well, we modify it by using an ensemble method like a random forest. Support vector machines don't have that same kind of issue because there's already this regularization built into it. So this is where I would say for like, as you guys get close to modify project, is definitely try out different, different machine learning algorithms and see how those perform. It's a great time for you to like really play around with and see how they perform and see what works well. And really a lot of it just ends up being a lot of practice, kind of like seeing how things get affected as you kind of change their parameters and see what things go through. I will recommend one book in particular. I usually say this until the end of this part, but I'll just share it to you guys now since we're talking about it. I'll send it on Slack too, but it's, let me just pull it up. Because I can never remember the whole title. So the whole title is Hands-on Machine Learning with Scikit-Learn and Tensorflow. This is a really great, like I would say, intermediate book. It goes through a lot of detail of like how to apply machine learning techniques to different data sets and the advantages and disadvantages and what hyperparameters that would be useful. It's not free, but I would say is that like it is totally worth it as a data scientist or a machine learning engineer. I'll put it also on Slack too. The author, I can never pronounce his name. It's I don't know if anyone says French. He says, like, I've heard him talk, and like when he says his name, I'm just like, I cannot reproduce that. I'm just not a good French speaker. But he's really great. He does a really, honestly, this book, I'm just like, oh my gosh, it's so well written. Also, I would say there's a second edition that just came out this year. definitely get the second edition. I got like an early release of it, and I had the first edition before, and I got the second edition. I'm like, oh, like he goes through a whole lot of more extra stuff. So definitely worth getting that second edition. But you can see here in this table of contents, he talks about machine learning in general, kind of like the process of it. And then he actually shows an end-to-end machine learning project, which actually is very similar to what you guys did for your very first project with the housing data set. But he kind of shows that in the machine learning focus. And then later on, he talks more about like other classification, supervised learning algorithms. And then he goes into, like, you see support vector machines in here. He talks more about like unsupervised learning. So you can see dimensionality reduction, unsupervised learning, clustering. And then he goes into more neural networks and more like recurrent neural networks, LSTMs, a little bit of NLP, but mostly saying like, okay, how do you optimize these things? So it's a great book. I have a digital copy, so I always forget like how big they are, but I've seen people have the book and it's like about like this thick, you know. So it's a pretty decent sized book, but again, I would strongly recommend it. In fact, I think, I don't know if I have it in here, but in some of my notebooks I have here, I reference some of his work that he does, because even if you don't get the book, which I still strongly recommend, he has a GitHub, and he has the code from the from his book as well. So you can see here, for example, I think he has one. I don't know if he has one about oh, he does have support vector machine one. So you can actually take this code right here from GitHub. You can download it yourself. You can actually run it in Google Colab. Have you guys seen Google Colab before? No? Oh, okay. Well, that's fun. Definitely tell Eli to show you guys more of this, because it's kind of a cool thing you can do. But basically, it's like a Jupyter notebook in the cloud that can run on its own like instance. And basically, you can go ahead and play around with the code that he has in here. Note that because if you look at it carefully, he doesn't have as much like text in between the parts, because most of that's in the book itself. But you can probably get most of the understanding of like how these things are working. Just know that some of it is not just saying, oh, just run this code, you know, and that's how it works. He's showing you for education too, of saying like, you know, this is what you would do. So you can see here, oh, he has something similar where he has like a different linear separators probably right here, and saying like how there's different margins. So you can kind of see a little bit of what's going on. But yeah, this is where I tell all my cohorts that go in through this part, highly recommend this book as they go into the machine learning aspect. I will say, since I'm already on this topic, might as well keep going. But I would say make sure you understand the basics. And basics mean like, you know how to use pandas, you know how to manipulate a little bit in SciPy, you know, understand the basics of matplotlib. And then this will make this book a lot easier in the sense of like, you don't have to worry about like, oh, do I know how to map? You know, do I know how to plot? Do I know how to use pandas? For you guys' level, I would say this is a perfect point for you guys. You guys have been doing this the past few months using pandas and everything. So you guys would likely be able to understand this pretty well. And he does a great job, I think, like explaining it, of not just like giving you very brief conceptual parts, which sometimes I've seen resources do where they go very like, oh, a neural network is just like a machine that does this, but doesn't really explain like why or how it's working. And then the other direction where sometimes people go a little too technical with the math, where you kind of lose like, well, I understand the math, like maybe you like are familiar with calculus, you're familiar with linear algebra, but I don't really understand how this connects with what we're doing. I think he finds a good balance in here. So again, highly recommend his book. But I will mention this part is that there's another book that I always mention that very early on, is the Data Science Handbook. So this one's by Jake Vanderplas. So the Python Data Science Handbook. Jake Vanderplas is a really early person. I'll put both of these things on Slack too, just so you guys have it. Just remind me if I don't. But he does a great job of, well, he was one of a really early contributor to Scikit-Learn. So Scikit-Learn we've been using. Funny enough, this might be why I really like him, is that he was actually in physics. He was astrophysics. And so he actually came from that background, but he's always been really big on open source. And so what's really cool is that this book, which I highly recommend, you can buy it, but it's also free online. Like it's actually like, if I go through this whole thing, it is completely accessible. Like you can see here, going through everything, the code. And this does a great job, again, open in Colab, This is all on GitHub as well, but the book's completely up on here. And he goes through basically like the introduction of NumPy, showing how to like use pandas, how to visualize with Matplotlib, and then he talks about some machine learning aspects here too. So you can see here, definitely like this last chapter, you can see how much smaller it is. I would say like this is the perfect, like if you were to like go through this whole book, like, and you're like, okay, everything sounds good, this machine learning aspect would dive you right into hands-on machine learning with this author. So yeah, a couple things for you guys, since you guys are kind of at this level now in module 5, where you guys are like, okay, I understand how to use Python and everything, but this machine learning aspect is such a huge part. So yeah, cool.
Thanks.
Yeah, no problem. All right, so I will go back then into support vector machines. Sound good? And I'll make sure if I forget for some reason, just remind me and I'll send you guys the links for both of these books so you guys can have access to that.